Hello, you are welcome to today's lesson. And today's lesson is going to be the continuation of our previous lesson. Okay, our lesson on circle theorems, plane geometry 2. Okay, in our previous lessons, okay, we did theorems 1 up to what? Up to 5. Okay, we did the first theorem that we looked at was, okay, same segment theorem, which is angles in the same segment. And we said angles in the same segment are equal. We also did angles in the opposite segments. Okay, and we said angles in the opposite segments are supplementary. Okay, then we did the center and circumference angles. Okay, and we said the angle subtended at the center, okay, is always twice the angle subtended at the circumference by the same arc or chord. Okay, then in our last meeting, I think we looked at what? Two more theorems. So we have said 3. Please, I want you to tell me the exact theorems that we learned in our previous meeting, in our last meeting. I've mentioned the last 2 meetings. Any of the theorems? You put up your hand. Try to recall without, okay, looking at your notes. It shouldn't necessarily be in the exact words that you were given. Okay, if you understand, you can put it down in your own words. Okay, however, there are technicalities involved in terms of the words that you are supposed to use. So if you say it and it lacks, okay, any of the technical words, I will draw your attention to that. So don't be afraid to, okay, make us proud. I'm waiting. Any of the theorems? We just even made use of one in the previous assignment. I'm waiting. Okay, Amma.
Sir, please. One of the theorem is the angle a diameter subtends at the circumference of the circle is equal to 90 degrees.
Perfect. Okay, so the diameter subtends an angle of 90 degrees at the circumference of what? Of the circle. Very good. And the last one, which is the 5th. Anyone to try? And I said the last one, the 5th one, we just made use of it. Okay, when we were looking at the solution to the assignment. So that one, if there is any one that we should forget, it shouldn't be that one. Anyone? Otherwise, I will mention names myself. Okay. Chrysler, let's go. Hello, Chrysler, are you there? Let's go. The last one. The theorem 5. Chrysler, please unmute and respond. Come again.
Hello.
Yes, I can hear you now. Yeah.
What are you saying?
He said, what was I saying?
Yes, please.
Hey, so where were you? Were you in class?
Yes, please.
No, it can't be. I doubt. Because I asked the question severally. All right, I'm not going to repeat it for you. Okay, so let's see. So that next time you'll be very attentive. Elvina.
Hello.
I can hear you.
So please, the theorem 5, I didn't join class when you taught it.
Which one? The theorem 5?
Yes, please, I was not in class.
No, it can't be. All the lessons are on the platform, so I won't take this as a reason at all.
No, what is it?
You've not watched it. The last time we did come out was last week. You've not watched it and you are here. Like seriously. Okay, this one day I'll report you to your parents. I don't like this attitude. Not at all. Hilda, let's go. Hilda, are you there?
Yes, please, Mr. Ackman, please, I just joined.
What do you mean by you just joined? Why did you just join? Today I will expose all of you in one way or the other. Why did you just join? You know the time that we are supposed to meet. So why did you just join? Meanwhile, I told you that you are supposed to join by 7 a.m. So why did you just join? All right. Okay, so I know how to deal with all of you. Reports will go, and I'm noting your names down. Okay, all right. You want to make the work difficult for us. It shouldn't be. The A is for all of us. And like I always say, whatever that I will do for you to get the A for us, I will do. I don't mind stepping on your toes at all. Okay, I have my eyes set on something, so I will get it. Okay, by fair means, anyway. Look at the way Blaze is happy. Okay, anyone to help? That you're in 5. Okay, so Adama,
The opposite angles in a cyclic quadrilateral are supplementary.
it's simple, as simple as that. Okay, so when I said that that particular theorem has what the opposite, the angles in what in opposite segments embedded in it. So if you forget the cyclic quadrilateral, okay, sort of, you can use okay the angles in the opposite segment theorem. Okay, it is basically the same. Okay, thank you very much. I know you know, and okay, so please, anytime a video is put, it is for you. Watch it before you come to class. Okay, especially those who will miss that particular lesson. I don't have to tell you to watch it. You know, once that lesson is missed, you are supposed, because we are burdened on. Other than that, you are setting yourself up to fail or to struggle in the subsequent lessons. So please make it a point to watch the video before, especially where you have that okay time length okay to watch. I won't take it at all. The next time this happens, I'll remove you. And once you are removed, you cannot be part of that lesson. Next time I won't take it easy at all. Okay, all right. So this is what we have. Okay, we are going to look at theorem 6, our next theorem. Okay, and you can see, and I read, two equal chords of a circle. So it means I'm talking of chords of what's the same length. Okay, they are equal in terms of length. Okay, subtend equal angles, 1 at the center of the circle, then 2 or B, okay, at the circumference of the circle. So immediately you see chords of the same length, that is equal chords, you should know that if each of them, okay, subtend a certain angle at the circumference, okay, the angles that they subtend, each of them subtend will always be equal once the chords are equal. So equal chords, equal angle at the circumference, equal chords, equal angle at the center. Is my point well made, or I should come again?
Please come again.
Okay, all right. So I will come again using the diagram, okay, that we can see here. If you look at this diagram, you can see that you can see two obvious, okay, triangles. This triangle and this triangle. Is that clear?
Yes.
I'm just bringing in triangles, okay, for you to relate. But whatever I'm saying has nothing to do with triangles, basically. Okay, so here, if you take the first triangle, you can see that each side of the triangle is a chord, true or false.
True.
True. The same for this particular triangle, the small triangle. Each of them with a chord. But if you look at the diagram critically, per your knowledge in geometry, you will see that, okay, two of the lines, that is for the two, or I should even say two of the lines are equal. Because in all, we see 6 lines, which will be 6 chords. But out of the 6 chords, okay, 2 of them are equal. True or false?
True.
Okay, which will be this one, okay, and this one. Is that clear? Because you know in geometry,
Yes.
we indicate equal length by using strokes. So equal strokes on a line will tell us that the lines are what? Equal. Okay, so now it means this chord and this chord, they are equal in length. Okay, so once they are equal in length, then a certain theorem or property will come out. Okay, and that property will be, okay, this two or these two equal chords. Okay, let's see. This chord subtend an angle at the circumference. Can you see that? Remember, I've told you if you want to see the angle that your chord subtend, the end point of your chord, okay, trace the lines there. Okay, where the lines meet, okay, that's where the angle subtended by the chord will be. So the end point will be here. If I trace the end point, the lines there, okay, it is forming the angle A for this particular chord. And this angle is at the circumference. You agree, right?
Yes.
Okay, in the same way, if you look at this particular chord, okay, it is equally subtending this angle B, okay, at the circumference. And once the chords are of the same length, once the chords are equal, you don't need a rocket scientist to tell you that, okay, your A, the angle A, okay, must be equal to the angle B. Because you can see that these two angles are all at the circumference and subtended by the equal chords. So indirectly, I'm trying to say that, okay, your angle here, which is what A, must be equal to, A must be equal to B for this particular diagram. If you come to this, please, it's my point well made here in terms of the first diagram explanation, connecting it, okay, to the theorem. We are all fine. Okay, perfect. If you come to this particular diagram too, obviously you can see two triangles. Okay, this triangle and this triangle. Okay, so once you can see two triangles, then indirectly, remember here O is the center. You are told that O is the center. Okay, so if O is the center, then it means my triangles here, okay, each of them will have an angle at the center. So I can see an angle A and an angle B at the center. But if you look at these two angles, A and B, you can see that A is being subtended by this chord. Okay, however, it is at the center this time round, not at the circumference. Can you see that? Hello, can you see that? Are you with me?
Yes, please.
Okay, in the same way, this chord is subtending the angle B at the center. But you can see that these two chords are equal in length. And once they are equal in length, okay, any angles that they will subtend, each of them will subtend at the center. Okay, it will always be equal. So it means here, okay, the angle A, again, must be equal to the angle B. All correct?
Yes, please.
Okay, very good. Per the theorem. So immediately you see, okay, equal chords. Check whether the chords that are equal are subtending certain angles at the circumference or at the center. Okay, if they are subtending angles at the circumference angles will be equal. If they are subtending angles at the center angles will also be what? Equal. Okay, so take note of that. Okay, now let me come to this diagram. This diagram is basically the same thing, only that if you look at it critically, you are unable to tell the equal chords. Okay, however, the chords that are equal will be called AB and called what? DC. So if these two chords are equal by using the strokes, okay, to indicate the equal nature, then you can see that if you look at the chord AB, it is subtending this angle at the point X, at the circumference. Am I right?
Yes.
Okay, and the other chord, which is of equal length to this, okay, is also subtending this angle at Y, okay, at the circumference. So once we are dealing with chords of equal length and each of them subtend angles at what the circumference, then you should know that these two angles, okay, will always be what equal. So it means if I look at the diagram, I can confidently say that angle AXB, okay, angle AXB, okay, will be equal to angle, okay, CYD, angle, okay, CYD. All correct?
Yes.
Just for the simple reason that we are dealing with what? Equal chords, angles subtended by equal chords. Okay. All right. Then in the same way, if you look at the chord, okay, A, B, and was CD, the chords A, B, and CD, you can see that if you look at the chord AB, it is subtending an angle at the center, and that angle, okay, at the center is indicated by the broken lines or the dotted lines that you have there. So this is the angle subtended by the chord at the center. Is that clear?
Yes.
Okay, so that is angle, okay, BOA. So angle BOA. Okay, and if you look at this particular chord CD, it is also subtending this angle at what? The center. Remember, O is the center. Okay, so in this case, what do we have? Again, this angle that we are referring to is angle COD. So angle, okay, COD. Okay, however, these two angles are subtended by equal chords, but at the center. So they will also be what? Equal. All correct? Okay, very good. So now, if this is the case, you are all fine. Please, is everyone fine? Is everyone fine? Okay, good. All right, okay. Kofi, are you fine? Okay, Gifty, are you fine? Okay, all right. Okay, so now, okay, so let's see. At this point, if you are okay with this, then we can move on to find, okay, or deal with what? Illustrative examples. So let's look at our first, okay, illustrative example. Okay, quickly. You can see a lot of lines, okay, but don't be worried. Just know your theorems and try to pick them out of the diagram. That's all. Okay, so you know, always when a question is given, I've told you for plain geometry, be it 1 or 2, when a question is given, set out your plan. So think through the question, go through the question, get to know of the angles that you will need to find the angle that you are looking for. Okay, once you're able to do that, then you go and present your solution. So in this case, we are going to study the question and it will help us present our solution. So what do we have? If you look at what the circle here, you can see, okay, two triangles, obvious triangles here. One, which is triangle QOR, and another one, which is triangle SOR. Can you see that?
Yes. Please.
However, I'm not much interested in what? In the triangles. Okay, here I'm interested in, I can see this line QR and this line SR. I can see that you are being told they are equal. Is that not it?
Yes.
Okay, QR is a chord and SR is a chord. You agree? So here we are confronted with two chords of equal length, which is equal chords. Okay, so once your chords are of the same length, you know, okay, that there is a particular, okay, theorem connected or property connected to that. And that will be angle subtended by, okay, at the circumference must be equal. Okay, the angle subtended at the centers must also be equal. So in this case, what do you do? Let's see. Okay, the chord QR. Can you see any angle at the circumference being subtended by the chord QR? Do you see any circumference angle subtended by QR? Trace the endpoint of QR and see whether, okay, the two will meet at the circumference somewhere. Do we? Hello, can we see, trace the lines, the endpoint, which will be the QR? Trace and get an angle, okay, their meeting point, okay, of these two lines are the circumference? No. Okay, same for SR. So it means here, though you know the theorem connecting the angles at the circumference, you don't have circumference angles for you to deal with. Okay, however, remember there is another, okay, theorem connector, which is the center one. So let's go and see whether we can get the center angles. Okay, so if you look at this QR, remember in this diagram, O again is the center. Okay, so let's trace. Okay, QR. You can see that the line, okay, from Q, okay, and from R, the extreme point, they will meet at the center, forming the angle 50. Is that clear?
Yes.
Okay, if you come to SR, SR also the end point. Okay, if you trace, you see that the lines there, they are also meeting at the center. Is that clear? So indirectly, you can see that now I can apply equal cos at the center. Equal cos angles at the center. Okay, so we know since, okay, the cos are of the same length, okay, it means they will subtend equal angles at the center. So if you know the angle subtended by this chord at the center, which is 50, you should know the angle subtended by the other chord, which is equal in length to 8. Okay, and that will also be what, 50. Is that clear? So it means this is 50 degrees as well. All correct?
Yes.
Okay, so now, okay, we know this is 50, this is also 50. Remember the purpose, okay, the goal is to find the angle x. We are finding the angle x here. So at this point, okay, you can see that you've made use of what the theorem that we just learned. Okay, which is the equal cos, okay, angles at the center will be equal, angle at the circumference will be equal by this equal cos. So in this case, we cannot use that theorem again. We have to rely on, okay, the other known theorems. Okay, Blaise. Blaise, unmute then. Take the stage.
Half of 100 degrees.
X will be equal to what? Half of what? 100 degrees. Very good. Okay, so you know, in this case, okay, you can see an angle at what? At the circumference. Okay, which is the angle P here. Okay, so this angle P is at what? The circumference, and it's being subtended by the arc or chord Q what S. And in this same arc or chord QS, that is subtending the entire angle here. Do you agree?
Yes, please.
Okay, please, who wants me to come again? I've told you that the theorems, you won't see it directly. Okay, I mean straightforward. Sometimes we'll bring in lines just to disturb you. So you just have to take out the irrelevant lines, okay, and deal with your theorems. Okay, Frimpong, Ekuya.
Sir, please, I wanted you to come again.
Okay, Adelaide, same.
Yes, please.
Okay, no problem. All right. Okay, so as for the first one, using the equal cos, you are fine. Is that not it?
Yes, please.
Okay, at that point, I should have left you alone. Okay, to continue, because I'm here for theorem 6. Okay, however, so because the other ones, okay, by now you should be perfect, but no worries. If you don't get it, that's why I'm here. Okay, so here you can see, okay, indirectly take out, okay, this particular line. Just break it down. If you take out that particular line, this becomes the diagram. Okay, so my center, okay, and this will be it. If I take out this line, then this will be the picture. Can you see that? This angle and this angle. This angle is the one that is broken down into 50 and a 50. Is it clear now?
Yes, please.
Okay, so you can see that this line is basically a disturbance. Okay, basically to throw you off gear. So that's why I said, if possible, take out the lines that you don't need and apply your theorems. Okay, with time, some of these things, when you see it, you can even, okay, get whatever that you are looking for, okay, without even taking it out, like Blaise was able to do. Okay, you should be able to figure out the angles that you will need without taking out any lines. If it is there, it shouldn't disturb you. You know your stuff. That's my point. Okay, so if you are all fine, okay, then I guess I can move on. And remember, we said if you look at the direction of the arc here and the direction of the arc, that is the circumference angle arc and the center angle arc, they are in the same direction. So it means these two angles are the circumference and center angles that are directly related. Remember, I talked much about this. So in this case, I know that the x will be equal to half of what? The entire angle here. So I know my plan. So I'm going to put my plan in my presentation. Okay, so what do I write? I write solution. Okay, once the vertices are given, and you can see that you didn't introduce any angle, any vertex. Okay, you didn't extend any line. So it means in actual fact, your solution, we don't have to see the diagram in it. You can make your point using the vertices. And I told you once the vertices are given, then it means the question probably wants you to use the vertices to carry out your explanation or your points. So in this case, what do? We are going to write, I know, first of all, we need to find this angle, which we have. Okay, so we know that this angle Q, okay, angle Q O R, okay, is equal to angle, okay, SOR. Is that clear? Do you agree? We made that
Yes,
point
sir.
before. And what will be our reason? Okay, angles by equal cos. So it's equal, and it should be equal to what? 50 degrees. Remember, I told you when we were doing the other one, I told you that if you know the exact value, you can just attach the exact value straight away. So I know the exact value to be 50. So each of them will be 50, and I come and give my reason in brackets. Okay, angles by same chord. So angles by, sorry, equal, not same, by, okay, equal, okay, chords. If you like, you can embellish it with what at the center, but we know these two angles are at the center anyway. You get it?
Yes, please.
Okay, so now if this is 50, okay, and this is also 50, then we can get our x. So I can come and say that my x here, someone can write angle Q P what S. But once you know the value, you can use it as well. Must be equal to, we know this angle and this angle, we said they are related, and it should be half. Remember, the circumference angle is always half of what? The center angle, and the center angle is always twice the circumference angle. So in this case, half of what? Angle, and my center angle here is angle QOS. So angle QOS. All correct?
Yes.
Yes, sir.
But I know that angle QOS, okay, is okay made up of two angles now. This angle and this angle. So I'm going to write this to be equal to. So it means my S will be equal to half of, okay, 50 degrees, okay, plus, okay, 50 degrees, okay, which will give you half of what? 100 degrees. Okay, which in effect will give us what? So I'll draw my conclusion at that point because I will get my answer. So therefore, x will be equal to what? 50 degrees. All correct? Hello, are we there?
Yes, please.
Okay, Eresi.
Mr. Hackman, let's say, for instance, I wrote, instead of writing the angle QOS like you wrote, I wrote angle SOQ. So does it make a difference?
SOQ.
OQ.
There is nothing wrong with it.
Yes.
It's the same angle. It involves the same, okay, point and the vertices. And the angle, okay, the vertex that the angle, okay, is on, or we have the angle, that's where the center one. So once it is SOR, or sorry, SOQ or QOS is the same thing.
Okay, thank you very much.
Okay, unless maybe you are looking at this angle. Okay, if you are referring to this angle, this is just by the way. If you are referring to this angle, what did I say you should write? Because if I say QOR, it could mean this angle or this angle. But we said if you don't attach a particular word, okay, then you are referring to this angle. But if you want to refer to this angle, a particular word must be attached. What did I say? Who remembers?
Sir, please, I don't understand what you are saying.
Okay, you can see that if you just say ordinarily, someone can, to avoid confusing. If I say QOS, QOS could be this angle, it could be this angle as well. I hope you get my point.
Yes.
I mean here. So, and we said, if, you are referring to this angle, this particular angle, then you just mention QOS. But if you are referring to the angle here, you have to attach something. That will make us know that you are referring to this angle. So assuming in your presentation, the angle, the X, was rather here. If the X was rather here, then it means these two angles are not the one that are connected. It will be this angle and this angle. So if you want to find this angle, you have to state something to let us know that this is the angle that you are finding. Immediately you write QOS, then it means you are referring to this angle. But if you want to be exact, in terms of the angle here, you referring to it, you have to attach something. I said I've made this statement before. What you are supposed to do. Anyone? Hey, does that mean you people are not revising? Very soon you write your test too. Remember I said you attach reflex then before you bring the angles. Do you remember? I guess you remember
Yes.
now. So please, now don't let us leave you. All right. So let us stick with you, forever. So now that was just by the way. Okay, Racy.
Mr. Hackman, please, I want to, let's say that we weren't given this 50 over here, like this 50 over here.
Mm-hmm.
So, can you, let's say, like, the 50 was rather given at the back here. The
At the
50
back.
wasn't here, was here. Here. Eh.
As
What
soon
the
as
arrows? Sorry.
the
Sorry,
way
I'm
you
not
said
seeing my screen. Sorry.
don't mind me. So it's okay.
Say, the
Where,
what the
where?
arrows?
No,
What
mention
the
use
arrow?
use the vertices. If you use the vertices and mention the
Okay.
angles, I will get it.
Okay, angle SRQ. If the
S
50
S R
RQ.
Q. If the 50 was here,
No,
don't
no, no, sorry, SRO.
S R O.
Angle
If the 50
SRO. If
was
the
here.
50 was here,
Mm-hmm.
yes. Would you use cyclic quadrilateral to solve it and get a 50 here?
Cyclic quadrilateral.
Yes.
If this is 50.
Yes, this place.
No,
That place.
okay, so let me be exact. I want to know whether before I have to understand your question. So this angle. You
Yes.
this angle,
It's
if this is
50.
50. Uh-huh.
Yes. And then X is over here like the way it is now. But there is
Okay.
no 50 like at the center.
Oh,
There is no
no, so
figure
it's,
at the
you
center.
mean this 50 is what you brought here?
Yes.
Okay, assuming that's the 50. You want to use
Yes.
cyclic quadrilateral.
No, I'm asking if it's possible to use cyclic quadrilateral. Like if
Okay,
questions can come like that.
okay, yes. You can use cyclic quadrilateral, but before you use cyclic quadrilateral, remember the cyclic quadrilateral, you connect opposite. Okay, obviously you've seen that the quadrilateral here, that is PQRS. It's a cyclic one. Okay, so once it's cyclic, then it means possibly you can make use of the cyclic quadrilateral, which, we could have handled it from another perspective. I will come to that anyway. So assuming this is 50, now let me answer your question directly. If this is 50 and you want to use cyclic quadrilateral, then it means you want to use the entire angle here and the entire angle here, because this will be the opposite angles. That will help you find the x. All correct?
Yes, sir.
But you can see that once if I know only this 50 and I don't know this, it means indirectly if I form my equation to involve two unknowns, because I don't know this angle too. Because I will equate the entire angle here, I will add the entire angle here and the entire angle here, to give me the 180. Meanwhile, I don't know this. So it means before I can use the cyclic quadrilateral, I have to come and find this angle. Afa.
Yes, Alpha.
Okay, very good. However, okay, remember I've told you in every question, if certain figures are clear, it means possibly we want you to make use of, okay, or making use of properties concerning that particular figure would be useful. Okay, in most cases. So here, assuming I don't know the equal cos theorem, okay, I can still find my angle S that I'm asked to find. Okay, and by that, I'm only going to explain. Okay, this is it, because this is the ideal way, ideal solution. But the other one will be, okay, a long route. So let's see. Okay, this is the center. You all agree. Is that not it? So if this is the center, then you agree equally with me that OQ, OR, OS, radii. True or false?
Yes, please.
Okay, so if that's the case, let's see, we are exploring, you see that we get the same result. If that's the case, then I don't need a rocket scientist to tell me that this, okay, side of the triangle is equal to the side of the triangle. And again, it's equal to the side of the triangle. All correct?
Yes, please.
Okay, so if I look at this triangle, obviously I can see, okay, an isosceles triangle. So once this is an isosceles triangle, this now becomes the base. So the base angles here will be equal. So I subtract this one from 180 and divide it by 2. So what will this angle give me? Okay, so I'm going to get 130 divided by 2, and that will give us 65. Is that not it?
Yes,
Okay,
please.
so it means I'm only giving you the alternative. So it means this angle is 65 degrees and this also 65 degrees. All correct?
Yes, please.
Okay, very good. So you know this to be 65, this to be 65. Okay, and once you know this side to be equal to this side, okay, obviously we also know that the base angles should also be what's equal. I hope you are with me. So 50 here, this will also be 65, 65. Is that clear? So I will now come and say 65 plus x should give me what? 180 degrees. In that case, I'm using what? Opposite angles of a cyclic quadrilateral. So let's try that and see whether we end up getting the same result. So I will say x plus 65 degrees plus 65 degrees, which will be the opposite angles of a cyclic quadrilateral. The entire angle here, okay, plus the angle here should give me 180. So 180 degrees. Okay, please, we are going to get x, okay, plus this will give us what? Is it not 130?
Yes,
Is equal to 180, and obviously you know x will still give us what? 50 degrees, which is the same as this. But you can see if you want to go that route, you have to stay isosceles triangle base angle. You will write a lot. So that's why I said there is usually not one way to solve it. However, you always have one ideal way. Is my point well made?
yes,
Okay, very good. Okay, the diagram is looking busy, but no issues. Okay, once you understand, I am fine. Okay, I'm not here because of the beauty of the diagram. Okay, all right. So now, okay, if you are fine, then let's move on to our next question. Okay, so this is it. Okay, a lot of, okay, size, okay, and I mean maybe extra information. So anytime you've seen triangles, you've seen, okay, a quadrilateral, okay, what have you, please take note. Try to bring out, okay, your basic, what do you call it, I should say properties of circle theorems that you know. Try to figure them out, okay, and see. Okay, all right, so let's look at this. With this one, we are asked to find again the lettered angles, so x, y, and z. Okay, so I'll give you some few seconds. Study the diagram that you have here, and let's see whether you can come out with your own way of getting any of the angles, either x, y, or z. Then we'll scrutinize what your understanding or your presentation. So I'm giving you about a minute. Please think through the question, set out your plan. When you are ready, okay, we'll come back and look at the solution together. Okay, so now that you are through with your plan, Amma, let's go.
Sir, please. This question, we have an isosceles triangle in the circle.
Okay, which triangle? So you say triangle, this is isosceles because you know the vertices.
Triangle PQS
Okay,
is an
perfect.
isosceles triangle.
Okay,
And isosceles triangle, their base angles are equal.
perfect.
So angle PQX is equal to angle PSQ,
Okay, which is equal to
40 degrees.
perfect. So it means this is 40 degrees. Please, do you all get her and agree?
Yes, please.
Okay, very good. Okay, so far so very good. So at this point, X, okay, will now be smiling at you. You found me. Okay,
Yes,
so
Yes, please.
all right. So you sum. So now you use the sum of the interior angle. So which other angle? Okay, can we easily find now?
X,
X and what? Y.
yes,
You found X, so you want to find Y. So how do you find Y?
opposite angles in a cyclic quadrilateral are
Perfect.
substituted.
Perfect. So please, this should always be the technique. When you see the diagram, try to fish out the figures that you can get out of the diagram. If you look at this, you can see triangles. So write triangles down. So indirectly, it means the question wants you to make use of what? The triangle, okay, properties, angle properties of triangles. Then again, oh, I can see cyclic quadrilateral. So once I see a cyclic quadrilateral, then possibly the question wants me to use what? The cyclic quadrilateral property. So I note that one also down. You get the point. Are you with me?
Yes,
Yes,
Okay.
please.
So in that case, you use the cyclic to find the y. Opposite angles should add up towards 180 and you find your y. Okay, then when you know y, getting z will be very easy. Okay, by using the sum of the interior angles of a triangle. Someone can also find the z. Maybe that's what someone want to say. So let me see. Ekuya, so your hand is up.
So I was asking about the why. I used another circle theorem, but it
Which
didn't
one?
have to do with the quadrature. The angles. Sorry, I used angles in opposite segments.
Oh, remember, I told you that angles in opposite segments is embedded in, okay, the cyclic quadrilateral. So remember I said, even today I've said it.
Oh, okay.
You remember, I said it today. Okay, so you can use the two interchangeably. Okay, they are the same, basically. Okay, all right. So it will be the same thing. You end up getting the same thing. Erase.
Mr. Hackman,
Mm-hmm.
please can you use to find the z,
Mm-hmm.
right? Can you use the let's angle QSP plus angle
QSP.
QSP,
Uh-huh.
yes, plus angle QSR
Uh-huh.
plus angle SQR
Uh-huh. S
plus
SQR. Okay.
SQR, yes, plus angle SQP
Okay. SQ.
is it- P
Very good.
is
Uh-huh.
equal to 180.
What is your reason?
Uh, at cyclic quad or
So cyclic
sub.
quadrilateral. Yes, opposite angles of a cyclic quadrilateral. Or you can also say angles in in opposite segments. Okay, it is true. That's why I said someone can choose not to use the triangle here to find z. You can use the opposite angles of a cyclic quadrilateral or angles in what? In the, okay, opposite what segment. You end up getting the same thing.
Okay, thank you very
Yeah,
much.
okay, you are welcome. So with this one, this is what I will do. Okay, I have walked you through how to get your answer. In fact, we have gone through how to get the answer. So what I will ask you to do, maybe as your assignment, I will put it there, then you will give me the way you carry out your presentation. You write it, you put it in writing. Is that clear? Okay, very good. So we are going to move on. I'm not going to provide the solution. Possibly you will do that. Okay, so as what? Your assignment. Are we all fine? Kofi, are you here? Is Kofi fine? Is Gifty fine? Especially those who joined us not from the beginning. Aris, are you fine?
Yes, please.
Is Sandra around? And Nanaya? Nanaya, are you around? Yes, Nanaya is around. Okay, let me officially welcome you. Okay, you are warmly welcome. Okay,
Thank
Nanaya.
you.
Okay, are you able to follow?
Yes.
Okay,
I'll
then
go over the videos
you
again.
go over the video again. All
Yes,
right,
please.
that's okay. You'll get it. It's not difficult at all. Okay,
Yes.
especially if you are okay smart as you are. Okay, you'll be able to get it. Okay, so I think Amanda, are you here? Okay, so are you able to follow
Yes, please, but it's my network.
your network? Okay, it's not
Yeah.
helping you. Don't worry. Okay, you get the video. Make sure you watch it. Okay, and if I set a deadline for your submission, okay, and you intend to watch it before, seek permission for late submission, but give your own deadline. If you seek the permission without your own, it goes to all of you, especially the new ones. If you are not privy to this information, seek permission for late submission. However, take note where your permission should come with your own deadline. If you're unable to meet your deadline, then I know it's intentional. Okay, if any permission, if you seek permission, even if I don't read it, once it comes with a deadline, it's automatically granted. But you have to seek a permission 30, at least 30 minutes before submission time. You don't wait when it's very close to submission, then you seek permission. No, I won't take it. That one is automatically not granted. But whether late or not, submit all assignments. Only that if you submit it late, you won't see it marked, but I will go through anyway. So all assignments must be submitted. Okay, thank you very much. So let's go. Okay, and look at our next question. Okay, a beautiful one like that. Okay, so please, all of you should put your mic on mute. Okay, so mute yourselves. All right. Okay, or your mics. Okay, so now look at the question. We are supposed to find the angles marked with letters. Okay, angles marked with letters. Okay, and this will basically be your assignment. This will be your assignment. I guess when you watch the video, you can do it. Is that not it? It's similar to what we just did, only that this time round, if you are careful, you will see that O is the center. Okay, in this case, you are told, in the question, you were told that O is the center. So if O is the center, then this line is what? Remember what I told you, steady. Okay, I can see triangles. So it means the question wants me to make use of triangles. Okay, I can see a diameter. Then it means the question wants me to make use of what? Theorem connecting what? Diameters. And you know, as you said today, okay, the diameter subtend an angle of 90 at what? At the circumference. So it means the easiest of the angle that you can get is what? The B angle here. Can you see that? Because that is being
Yes.
made by the
Yes.
diameter BC, and it is making this angle at the circumference, or this angle B. So I've helped you find the B. So you go and find the A, C, and D as your assignment. All correct?
Yes.
Okay, I'll put it on the platform anyway. Okay, so on this note, we are going to have our water break. When we come back, we'll look at our next what theorem. Okay, let me resume. Okay, Eresi.
Mr. Hackman, please, I was going through the past questions, and I saw a certain cyclic quadrilateral question, but I don't understand how they did it.
You don't understand how they did it.
Yes.
Okay. Was the theorem, the question, only about cyclic quadrilateral?
No, it
Or
wasn't
it
only
had
that.
it had other properties, other
Yes.
information. So don't worry.
Yes.
Okay, we are looking at the theorems in isolation. Okay, you can see that even sometimes when we are dealing with a particular theorem, you can see that the question will involve another theorem. Then that will help
Yeah.
us revise. So don't worry. When we are through with all the theorems, we'll go and look at general questions like we always do.
Okay.
Okay, likely exams questions.
Okay.
So it's possible maybe that question that you are talking about will handle it. If you
Okay.
bring it up, we all okay.
Okay.
All right, so now I want you to get all the theorems, okay, maybe basically in isolation. You can figure them out. Then we'll bring in more lines, like I said, just to see if we can confuse you. But trust me, if you get, okay, all your theorems at your fingertips, no question can trick you.
Okay.
All right,
Thank you
okay.
very much.
You're welcome. All right, so now we have our next theorem. Usually, okay, I tell students that, okay, this particular theorem is the most technical one. Okay, however, it is technical though, but when you get the concept, in terms of the technicalities, you will be very, very good to go. You will always find it very easy. So this is what we call the alternate segment theorem. Alternate segment theorem. So I'm going to read the angle that lies between a tangent and a chord. Okay, so you can see if you look at this, okay, particular theorem, this is where it applies. Before this particular theorem will hold, okay, you have to see a tangent. You can see that so far we've not made use of what's the tangent. So this is the first theorem that brings in a tangent. True or false? Okay, so once this is the theorem connecting, okay, tangents, okay, the first theorem. Now this is what we are going to do. With this theorem, you should have a tangent and you should see a triangle, okay, sitting on the tangent. But that triangle that rests or sits on the tangent should have all its vertices, okay, all the vertices at the circumference of the circle. So I can indirectly call it a cyclic triangle. Should I come again? Okay, all right, so I will come again. I said, before you can make use of this particular theorem, which I'm here to walk you through, okay, this is supposed to be the picture that should bring this theorem, okay, in play or to play. So now this is what we are going to do. I said, immediately you see the question and you see a tangent. Okay, however, the tangent has what? A triangle with all the vertices at the circumference sitting on it. Then it means we can make use of this particular theorem. So if you look at this diagram, you can see that this line here is a tangent. You all agree. Remember when we were looking at the part of a circle, we introduced the tangent. We said the tangent is any line that meets the curve at exactly 1 point. So any line that touches the curve at exactly 1 point, only 1 point. So this is a tangent meeting the curve at this point A. And you can see triangle ABC, okay, with one of the vertex, okay, sitting on what? The tangent, with the other two vertices at the circumference. So indirectly, you can see that all the three vertices are at the circumference of the triangle, at the circumference of the circle. So I can call this, okay, a cyclic triangle. Just as when I had all the sides, okay, of a quadrilateral, all the vertices, I should say, okay, at the circumference, we call that quadrilateral cyclic. So a triangle with all the vertices at the circumference, we can equally call it a cyclic what? Triangle. Is my point well made? Okay, so now let's see, okay, the exact theorem. So the angle that lies between a tangent and a chord. So you can see that I have a tangent. How many chords can you see in the diagram here? How many chords? How many chords?
3.
3. Okay, chord AB, chord what? AC, then chord BC. 3 of them. Okay, all the sides of the triangle, okay, will give us what? A chord each. Okay, so now what do we have? Okay, we have 3 chords. However, you can see that it is 2 of the chords, okay, that will make an angle with a tangent, or that is meeting, okay, the angle, what do you call it? That is meeting the tangent and forming an angle. Okay, the two chords, only two chords meet, okay, the tangent and form an angle. So I can see that chord AB, okay, meets my tangent here. Remember, an angle is formed when two lines intersect. Okay, so are connected. Okay, so in this case, you can see that there is an angle here, okay, between your tangent and the chord. Do you agree? Okay, there is
Yes.
another angle here which is marked in yellow and it's called theta. This is also the other chord and the tangent, the angle that it makes. So you can see that you have, okay, two angles made by a chord and a tangent. So we said the angle, okay, between a tangent and a chord. So I have one here, a tangent and a chord, this angle, okay, is equal to the angle subtended by the same chord in the alternate segments. Now, this is the problem. Okay, if you're able to know the problem and you know the solution, we are good to go. The problem is, how do you locate the angle in the alternate segments? Okay, for you to say that these two angles are equal, and I'm going to give you a very simple way to locate the angle that will be equal to the angle between this chord and the tangent. So this is it. All right. The chord at reference, okay, that is the chord that you are looking at. In this case, let me assume maybe I'm looking at the chord AC. If I'm looking at the chord AC, the chord that I'm looking at, it is this chord that makes this angle theta, okay, with the tangent. Now, how do we find the angle in the alternate segment? Just look at the chord. Okay, the angle that the chord subtend at the circumference, okay, will be the angle that must be, okay, equal to this, and that will be the angle in the alternate segment. Should I come again? Oh, my point is well made.
Please
Come
come
again,
again.
again.
I saw it coming. All right. Okay. I've never explained once when it comes to this. Remember, I told you it's a little technical, but not difficult. So, you know, this chord AC. If you want to know this chord, the angle that is obtained at the circumference, what do? You trace the endpoints, the lines there. You know, you know this trick. So trace. So AC at the end point. So if you trace, you see that AC, okay, if you trace, will form the angle theta at B. So this is the chord, okay, and the angle is obtained at what? At the circumference of the circle. And this angle that's your chord that you are looking at, which is making this angle that you are looking for, the alternate segment angle. The angle that the chord obtained at the circumference automatically becomes the angle in the alternate segment. That is one way of explaining the angle, okay, in the alternate segment. Another way, so I'm going to give you two ways. The one that sits well with you to recognize this angle in the alternate segment, you adapt. Okay, so please take note. Another way is to do this. Okay, so you can see that your triangle, every triangle will have three interior angles. Every triangle, three interior angles. Okay, you can see this angle, and this angle. The angle in the alternate segment will be the angle, okay, formed not connecting your chord, or with your chord not involved in the triangle. You can see that if you look at all the three angles, okay, this angle here is formed by this line and your chord. So this angle involves your chord. Is that clear? The formation of this interior angle also involves your chord, this chord, and another line. However, if you look at the other angle, the interior angle, this angle here doesn't involve this chord. Is that clear? So that will be the angle that must be equal to this, which will be the alternate segment angle. All correct? Or again, I should come again.
Please come again.
All right, okay, so no P, no problem at all. Okay, the first one, did you get it? How to trace the angle by the chord at the center, sorry, at the circumference, will be the angle that will alternate with this. Okay, in the alternate segment, I should say, and it will be equal to this. So now let's see. Okay, Amma.
Step, you are saying that the angle for AC mixed with that is equal to the angle at B,
Yes, the angle
right?
your chord makes with the tangent should be equal to the angle, okay, in the alternate segment. And the alternate segment angle, as for the angle between the chord and the tangent, you can easily get it. You get it. That one doesn't need
Okay,
any
sir.
explanation.
I
It's
want
the
to
other
ask that.
angle.
I want to ask that, but the angle at B, isn't it on a different chord?
Isn't it on a different chord as in this one?
Angle chord AB, yes,
Chord AB. This angle here.
yes,
Okay, remember,
yes.
we are connecting two
But
angles. Amma, relax. Okay, I get your point. Okay, you know
I
all the properties that we looked at. You can see that we didn't consider only one angle. We were connecting, okay, two or more angles. You get the point. So you are stating a relationship. You cannot state a relationship
yes,
with only one person. That's why you say that you are related to your sister, related to this, related to this. So you can't state a relation using only one person or using only one quantity. Is that clear?
okay,
So here you need to
yes,
know
please.
two quantities. But two quantities, one of them you can easily know. So in this case, okay, the angle that lies between a tangent and a chord. So a tangent and a chord. So this angle, is that clear?
Yes, please.
Okay, then we said it's equal to the angle subtended by the same chord in the alternate segment. This is where the technicality is.
Yes,
How to
please.
locate that angle. And I'm giving you a gist, a simple way to locate that angle without struggle. I said, look at the chord and the consideration, the chord that is forming that angle with your tangent, because it's this chord and the angle that is mixed with the tangent here that we are considering. So it means this is our chord of reference. Is that not it? Or a chord of
Yes, please.
interest. So this chord of interest, okay, all the chords, you can see that all the chords will subtend, okay, an angle at the circumference. If you take this to be a chord, it subtend this angle at the circumference. If you take this chord, it subtend this angle at the circumference. And if you take this chord, it also subtends an angle at the circumference. Is that clear?
Yes, please.
Okay, so now the angle that is subtended by your chord of interest at the circumference is the angle that must be related to this, and the relation is that they are equal. So that will be the angle in the alternate segments. All correct?
Yes, please.
Or I said, okay, you'll be dealing with a triangle sitting on it. So as for this angle, it's an exterior more or less angle of that your triangle. This one, if you extend, okay, so it's not exactly an exterior angle per se, because exterior angle will just come from the extended, okay, side, but this is not an extended side. Okay, I'm just using exterior for, okay, convenience sake, so please take notes. Okay, so in this case, this angle that you have here is not an interior angle. So this angle between the chord and the tangent, okay, must be equal to one of the interior angles of your triangle. And the angle, okay, that this must be equal to, that's the interior angle, is the interior angle formed, okay, not involving your chord. So if you look at all your interior angles, the only angle formed not involving your chord is this. Okay, this angle involves the chord. This angle also involves the chord, but this is the only angle that involves, okay, only this chord and this chord, but not the one that you are interested in. Afa.
Yes, please. Yes.
Okay, very good. So now let's come to this as well. Okay, so this is it. So another way of stating it, the angle between the chord and the tangent is equal to opposite angle inside the triangle. Okay, opposite angle inside the triangle. Okay, so that's another way instead of using the alternate segments. Okay, so now this is what we have. Okay, let me see before I come to this. Okay, if you look at this, assuming remember, we said two chords. Okay, meets the tangent. So if I look at this angle, the angle here, because this angle is formed between a chord and a tangent. Is that clear? Is that clear? Okay, so please study this one carefully. And based on the information that I've given you in terms of how to locate the angle, that must be equal to this. So if let's say I call this angle X, if this angle is X, okay, which of the interior angles here use the vertices, maybe triangle, angle ABC, angle CAB, angle CBC, CBA. Use that one to answer the question for me. Which of the interior angles of the triangle here, okay, triangle ABC, will be equal to this and will be the angle in the alternate segment based on what I've told you? It will be the angle at which vertex. Should I come again?
Yes,
Yes,
please.
please.
Angle
Okay.
BC.
What angle? What?
BCE.
BCA. Perfect. But some of you want me to come again, so I'll come again. All right. So we see now we use this angle, which is the angle between this chord and the tangent. Okay, to find the related angle, and the related angle is this. That is the angle the chord makes at the circumference, which is this angle. So this angle must be equal to this. That's why if this is theta, this will also be theta. Is that clear? Okay, but remember we said it's not only one chord that is meeting the tangent here. Okay, we have another chord here that is meeting the tangent. So I can also look at this chord and the tangent, the angle between them, which is this x. So the question is, which of the interior angles here, okay, must be related to this, directly related to this, and is equal to this? And okay, you just heard that it is this angle, just because this chord, okay, makes this angle at the circumference. So it will be this angle that will be related to this. So it is this angle that will also be x. Afa.
Yes, please.
Okay, so let me come to this diagram again. So if you look at this diagram, you can see that this angle 60 is made by this chord and the tangent. This is a tangent. Okay, so if I want to know the angle that will be equal in side to this, okay, of the interior angles in the triangle, let me look at the chord, the angle that it makes at the circumference. So this will be it. So this angle is the angle in the alternate segment, and that must be equal to this angle. If I come and take this chord 2, it makes this angle 70 with a tangent. So I need to look for the angle that is related to this, and the angle that is related to this will be the angle the chord, okay, makes at the circumference, your reference chord or your chord of interest. So if you look at this, it is this angle. If you trace the endpoints of the chord, it is meeting at what the circumference, forming this angle. So it is this angle that will be the angle in the alternate segment, and that will be equal in size, okay, to this. Afa.
Yes, please.
Okay, very good. All
Yes.
right, so very good. So this will be it for theorem what 2. However, let me see if I can play on your intelligence a little and maybe your understanding. Assuming I have this. Okay, I have a tangent. And remember, your tangent will not be always this. Okay, you can see that this one is just straight, horizontal. Okay, this one is diagonal. You can put the tangent anyhow. So take note. Or what is important is a tangent. So I have this to be the center. Okay, in this particular diagram, if this is the center, okay, O is the center, can I make use of the angles in the alternate segments? If yes, why? If no, why? I'm giving you 30 seconds to think through. Okay, when you are ready with your answer, okay, please tell me. Then we come back. Okay, so in this diagram, assuming you are given this diagram, okay, remember a tangent, only one tangent. Okay, so let's see whether we can make use of what the alternate segment theorem or property. So let's see whether this diagram we can apply that theorem. If yes, why? If no, why? That is the question. By now you should have your answers. Who wants to try? You pick your option, yes, you defend it, no, you defend it. As simple as that. And we'll see how you'll be able to convince me with your answer as well as the defense. Okay, Adoma.
I'm trying.
Okay, go ahead.
I think it cannot be applied
Why?
because two parts of the triangle is a radius and not a chord.
Two sides of that.
Yeah.
Okay, indirectly. Okay, you are not wrong. Though exactly what I wanted you to say. Okay, but indirectly, what I wanted you to say is what you've said. But I want just a simple language because I made an emphatic statement. Okay, let me see if, okay, someone, okay, I saw another hand up. Let me see who the person is. Okay, the next question.
That one, please. What I remember is you said all the vertices must touch the circumference of the circle. Or
Can you hear me clapping for you?
yes, please.
Okay, so that is it. Remember, I told you before you can apply this, the triangle sitting or resting on the tangent should be a cyclic what? Triangle. Is this a cyclic triangle? No, because one of the vectors, okay, is at the center, it's not at what? The circumference. Only two are there. So immediately you see this, it means you cannot apply that what. So be careful. Students see this and they will say that this angle here and this angle are equal, which is not so. Because, okay, before you can apply this, there is a condition. And that condition is not met, so you cannot apply. So thank you very much. Okay, Adoma and what? And Nene Ekia. Yes, Blaze.
Mr. Hack,
Yeah, Blaze.
my network, I couldn't hear.
You couldn't hear.
I couldn't hear the condition.
Okay. No, we just said that from this diagram you cannot
Yes,
apply
please.
you cannot apply the theorem just because the triangle resting on the tangent is not exactly quadrilateral, meaning it doesn't have all the vertices at the circumference of what of the circle. As simple as that. Okay. All right. So now let's go and look at illustrative example and see how best we can deal with these questions. You are doing well. All right. So now let me see. Okay. Interesting. Adama, I won't mind you. I won't mind you. Okay. I clapped because she gave me the exact answer. I told you yours was indirect. Okay. I wanted a direct answer. So that's why at the end, I acknowledge you and I thanked you. Okay. All right. I won't mind you. Okay. So now let's see. Okay, so next time give me the direct one. I'll clap for you. Okay, so if you look at this diagram, you want to figure out the angles that will be the alternate segment angles, and that will be equal to the known angles here. So that's all that we are going to do. So I'm going to label the vertices. Okay, then you will tell me. Okay, so just for convenience sake, so A, B, C. So you tell me the angle. Okay, so P, Q, R. Okay, then maybe again, let me use, C, D, E. Okay, so you tell me the angles. Okay, that will be in the alternate segment. So let's look at the first one. You can see that I'm considering this chord AB and the tangent here. Okay, and the angle is formed between the chord and the tangent. So which angle will be equal in size, okay, to this? Equal in size. Okay, meaning the angle in the alternate segment. Okay, Adama, do you want to take it so that I can clap for you? Okay, okay, that's all.
Please, I think it's angle ACB.
Angle, you think or you know?
Um, I know.
Okay, so it's angle ACB. Okay, why? And use the language that I have used. Okay, how to determine, okay, that angle. Okay, so why? Why should it be this angle? You are right, but why should it be that angle? Maybe you said this is it. This is because you use a particular technique in making that determination. So how or why? Ekuya, Ekuya, we are waiting. Oh, you just know it by instinct. Oh, it's your network. Ekuya, are you talking? We can't hear you. Okay, all right. Who want to give the reason? What is the reason? In any case, your reason will be angles in the alternate segment or alternate segment angles. Okay. However, how were you able to identify this as the alternate segment angle? That's my point, or that's the question. Ekuya, do you want to come in again? How were you able to identify that angle? Uh-huh. Okay, all right. It seems I don't know. Okay, Aris.
Mr. Hackman, please. I think it's because the angle between the chord and the tangents are equal.
The angle between the chord and the tangent are equal. Are equal to what?
To the opposite angle inside the triangle.
I like that. You people are smart. Oh. The way sometimes you answer the question smartly, you put me in a tight corner, whether to say you are right or wrong. Okay, all right. So no problem. You use the second one, the interior opposite angle. Okay, that's how you use. Are you able to make that determination? That's fine. Okay, but in fact, I wanted you to use maybe this chord. Okay, because this chord, the chord of interest, subtend this angle at the circumference. That's all. Or, okay, this angle here is not, it's an interior angle, not, okay, involving your chord again. Because these two were the major reasons I gave you. Am I right?
Yes, please.
Okay, very good. So going forward, I believe you will know what to say. Okay, so well done. You are doing, okay, so well, keep it up. Okay, so at this point, this is what we have. So it means it is this angle that will be 44 degrees. Okay, to be in the same, okay, I mean size, or to be of the same size. So now if you come to this, it's the same concept. Okay, if you look at this angle, this chord, it must be equal to the angle made by this chord at the circumference. This chord is making this angle at the circumference. Okay, only this angle. So it means this will also be 42 degrees. I hope you are following.
Mr. Hackman,
Yes, please.
please, I don't understand.
Okay, Karen, which parts don't you understand? From the beginning, from the theory, we were able to relate.
No, I didn't understand the theorem well. That's why.
Oh,
So
Karen, you know the rule now. Why do you do this?
Mr. Hackman,
Why do you do this to Mr.
I
Hack?
was having connection problems, so I joined the class late. And when I joined, you were halfway through the explanation.
Of this one?
So yes,
Okay, so you decided to keep mute.
and try and understand from where you were going.
Okay, but going forward, you realize that it's still not helping. Okay, then maybe let me plead with you. I will still have you in mind whilst I'm explaining. Okay, but wait for the video, okay, and see whether, okay, if you start with us, okay, you will definitely get exactly the point that we are making.
Thank you.
Okay, thanks for your understanding. All right, okay, so now this is what we have. Okay, we said we are looking at angles in the alternate segment. So what is important is the angle in the alternate segment connects, the alternate segment theorem connect two angles. One of the angles will be the angle, okay, by a chord and a tangent. So it means this is the angle that is given, one of the angles. The other angle will be one of the interior angles of your triangle sitting on your tangent. And how do you locate that angle? I said you can easily locate that angle, that interior angle, by looking at the chord. The angle that chord that is making that angle at the with the tangent makes at the circumference is the angle that will be the alternate segment angle, and that will be equal in size. So if you come here, you can see that you've been given the interior angle rather. Okay, so with this, the interior angle here, it must be equal to one of the angles made by the chord and the tangent. And you can see that we said, okay, if you want to look at the chord and the tangent, that will talk about one of the interior angles connected in terms of connection. Okay, that chord shouldn't have anything to do with this angle. So if you look at this tangent is made up, has two chords meeting it. You can see this chord and this chord. Is that clear? However, the interior angle that we have here, you can see that the interior angle has a connection with the chord, this particular chord. Okay, so it means it is not this angle here that is related to this, but it's rather the other chord. So if you look at the other chord, you see this. It is this chord that is rather making this angle at the circumference. So again, you can trace the angle, the interior angle of that triangle. You can trace the size forming that angle. If you trace, you see that it will end you, it will take you to the chord. Okay, that is making this angle with the tangent. So the chord of reference will be this chord rather. So it is this angle that must be 66 degrees. Point well made. So it means this angle will also be equal to this angle. Is that clear? And okay, this angle here will be equal to this angle. And if you take this angle, which is also by a chord and a tangent, it will be equal to this angle because this chord subtend this angle at the circumference. Or if I take the triangle sitting on it, this is the only angle that has no connection with my chord. All correct? Okay, so Amma.
Could you go back?
Okay, all right.
Yes.
Okay. Amma, I've gone back. Hello? Amma, are you talking that I can't hear you? Okay, so let's see. If she comes back and need be, we'll go back. So let's move on. All right, so with this one, we need to find x. So this one, we are going to present our solution together so that you know the best way to go. Okay, so remember, in this case, you know the size of this x. So let's see, I know an angle here, which is between a tangent and a chord, this angle. So this, and equally, I see a triangle resting on it, and that triangle is a cyclic triangle, meaning all the vertices are the circumference. This vertex is at the circumference, vertex at the circumference, vertex at the circumference. Okay, so now we know we can apply that alternate segment theorem. So this chord, which is making this angle, the same chord that is making this angle at the circumference. So it means this angle and this angle should be the same. So I'll write, therefore, my x, will be equal to 70 degrees. Okay, what is your reason? It will be alternate segment angle. So alternate segment, okay, angles, or angles in the alternate segment. Is that clear? Hello, is my point well made, my professors?
Yes, please.
Okay, very good. Then we move on to, okay, the next one. Okay, we need to find x and y. Okay, if you look at this critically, okay, you see that this angle 60 is made by this chord. Okay, and this chord, got the chord and the tangent, and this chord makes, okay, this angle at the circumference. So these two angles are related. And again, if you take this chord, okay, it makes this angle with a tangent, and this chord is making a certain angle at the circumference. So we can again apply the theorem. So we are going to write, the first one will be therefore x will be equal to 55. Do you agree?
Mr.
Uh,
Hackman,
yes, please.
can I ask a question?
Okay, if not, why not?
What about the angle that is inside the triangle?
Okay, so you can see that all along, the angle here, the interior angle here, formed by your two chords. Okay, we are not talking about that angle. So it will be the other angles. However, if you want to find this angle, you can use angles on a straight line. Or if you know x and y, you can use interior angles of a triangle.
Okay.
Okay, all right, okay. So now, what do we have? We are going to get our reason, state our reason, and that will be, okay, alternate segment angles. Okay, then again, therefore, y will be equal to, and y will be 60 degrees, the same reason. Okay, you write the same reason. You cannot do this, please take notes. Okay, you have to write everything there. I'm writing it just to save time. Is my point well made? Please, are we fine? Especially Karen. Karen, are you fine now? Is it better?
I'm understanding it bit by bit.
Bit by bit. Okay, so maybe bit by bit it will be full. Okay, by the time we end. All right, so once you are understanding bit by bit, it's better. We are making progress. Okay, however small, it's a progress. Okay, so now let's see. The next one. Okay, so this time right is x, y, z. Okay, you can see that z is the one that you can easily find. I'm only going to explain, I won't write, because you can write angles on a straight line, 65 plus z. I usually want to write my letter first. So I'll write z plus 65 degrees plus 35 degrees is equal to 180 in brackets, angles on a line or on a straight line. Then you go and solve for your z. Is that clear? Okay, then if you look at the angle 65 here, it is formed by this chord and the tangent. And this chord is making a certain angle at the circumference. So the chord, the angle that it makes at the circumference will be the angle in the alternate segment that must be equal to the angle the chord makes with the tangent. So it means x will also be equal to 65. In the same way, if you come to this y, if you look at y, okay, y is directly opposite this chord. Okay, so it means it's this chord that is subtending this what angle, y, at the circumference. So the angle that this chord makes with the tangent will be equal to this angle, because that will give us the angle in the alternate segment, and that will be it for. So it means y will also be what, 63 degrees. Point well made.
But
Yes, please.
that's what people do what you just said. Like I was having
Okay, who is that?
Crystal. I didn't hear you clearly.
Okay, all right. Okay, so I said finding the z should be very easy for all of us. Okay, because we can use angles on a straight line. Okay, it has nothing to do with circle theorem 2. Oh, sorry, plane geometry 2, circle theorem. So in this case, angles on the straight line, z plus 65 plus 63 degrees should give you, your 180. Then again, this angle here, one of the interior angles here, will be equal to one of the angles between the tangent and the chord. And we said it will be this one instead. Okay, because we know it is this chord that is forming this angle at the circumference. So this will be the alternate segment angle, and it will be equal to this. If you come to this angle too, you can see that this angle is formed by this chord. So it means this chord, okay, the angle that it makes with the tangent should be equal to this angle as well. Crystal, is it fine now?
Yes, please.
Okay, good. Okay, so at this point we move on to our next one. So this will be obviously, this Ekuya Danso.
Mr. Hackman, please, sorry to take you back, but I went off, so I didn't see how you present the
Which one?
the answer.
This one.
I don't know which one you for one of them you presented it for us to see, but I
Yeah,
went off
this is
during
it.
that.
This is it. We started from here. The first one,
Okay,
second one. So
yes,
this one. Okay, so it's your reason that what exactly what to write, but you know the
or
relation. So you just write alternate segment angles or angles in the alternate segment. But I know that if I
yes,
write alternate segment angle, I've taken out in and the d. Okay, so it means I've saved time. However, let's say by establish the same point. You get the
yes,
point.
yes, please.
Yes.
Thank
All right. You are welcome. All right. So that will be it for this, and this one too, is the same thing. This x will be equal to this angle. Okay, this y will be equal to this angle. So take notes. All right. Okay. Then basically, it's the same situation here as well. Okay, x will be equal to this, y will be equal to this. Okay, all right. So at this point, I think this will be your assignment. I will leave this one with you as your assignment, maybe together with the first one. Okay, God willing, tomorrow we'll meet and it is left with one more theorem to go. Okay, unfortunately, I don't want to rush you through that theorem. Okay, so God willing, tomorrow we'll have a look at that theorem. Then after that, we'll have time to handle general questions, likely exams questions. All correct? Okay, so at this point, thank you very much. Okay, if you don't have any questions to ask, any contributions, we are bringing the curtains down, on today's lesson. Okay, so God bless us all. Okay, bye-bye.